girls, flip-flop comes from latches. So now you learn the concept of latch. So you should know now the concept of flip-flop. So there is there is not too much difference between latches and flip-flop. I think I already explained you in the class what is the difference for latches and flip-flop. For latches, you can see we are using control enable, huh? Am I right? But
Yes.
if I am saying that I want SR flip-flop, then what should I write here?
Clock.
Clock. Okay, and flip-flop works on the age triggering. Did I explain this or not?
Yes.
Yeah, so flip-flop will works on age triggering, but the latches works on label triggering, huh? Positive, negative.
Yes.
Okay, that's fine. So we have done this, alhamdulillah. Okay. Now SR flip-flop. So now this is SR flip-flop here. So we have the same table, it has the clock. Now let's start to solve this waveform. So girls, you need to read it carefully first, and then you should understand, and then we will start. The question is, determine the output of PGT. PGT means PGT means is positive, going, triggering. PGT means age triggering. They are talking about age triggering, and positive means when it goes up. Okay. Clocked SR flip-flop, and because do you know they mention here SR flip-flop, so we know that for the flip-flop it is age triggering. Clear?
Yes.
Okay. Now what they have given us, which Q initially 0 means what is the Q they have given us? Initial Q0 they have given us 0, means this is in the memory now. Clear?
Yes.
Okay. Given input waveform, for the given input waveform. So we here they have given us the clock. So we know that this flip-flop will work only for positive because they mention here PGT. So it will work for the positive, and S and R is here, and we need to draw this. This is the output. Q and Q bar. We need to draw, okay? It's already here, but I will explain how this output will come. Understand what we need to do, girls?
Yes, miss.
Okay, so let's start to draw the first truth table. So if there is a clock, if no clock, this is S and R, and this is the value of Q. If no clock and S and R, you are giving whatever the value, it will work as a
Memory.
memory. Now you are giving the clock, and if it is 00, definitely it will work as a memory. Now you are giving the clock and R is 1, so it will become reset. You are giving the clock, S is 1, so you will get 1. You are giving the clock and both are 1, so it is called invalid. Clear or not?
Yes. Clear.
Okay. So let's start here. Look, the clock will start from this point. But before this point, we need to find the result. Look, what is the value of SNR here?
0.
00. And do you know here, the clock will start from this point. From this, I will use another color. The clock is starting from this blue point. So before that means no clock. Understand this condition. So if no clock, whatever the value of SNR doesn't matter. It will work as a
Memory.
memory. And what is in the memory?
0.
0.
So that's why Q will be 0 here. And it is before the clock. Clear? Clear or not?
Yes, yes. Clear.
Okay. Now it's the time for the clock this time. So this is the time where the clock you are in the flip-flop is getting. So here we need to check what is the value of S and R. So what is the value of S and R here?
X. Don't care.
S,
0.
S 0 0 both values, huh? If both are 0 0, it will work as a,
Memory.
Memory.
what is in the memory now?
0.
0.
So continue to 0 till to the next. Clear?
Yes.
Okay, now again this is the time to change the result. At this instant, it is the time to change the result. So here the value is S is 1 and R is 0. So if S is 1, then
0.
S is 1.
Then it's set and the
Okay,
output is 1.
Yeah, so that's why it's 1. Clear?
Yes.
Because it's
Again, yeah, because it's set condition, huh? Again here, this is the time to change the result at this point. So check what is the value of S. S is 0, R is 1. So if R is 1, then
0.
0. So it goes back, okay, to 0. Got it? Now again time to change the result here at this age. S is 1, R is 0. So,
Up 1.
so set. Clear or not?
Yes. Clear.
Clear to everyone?
Yes.
And Q bar is the complement of this. So it was 0. So this is 1. This was 0. So this is 1. This is 1. So this is 0. This was 0. So it is 1. It was 1. So it is 0. Just complement. Clear?
Yes.
Okay. Now let us start. Determine the output of PJT clocked SR flip-flop which Q initially 1. So what is the memory result they have given us? In the memory, it is 1. Okay. Okay. So now here clock is 0. So if clock is 0, then it will work as a memory. So what it will store now?
1.
1. That means this value is 1. Okay. After that, this is the time where the result will change. So check what is the value of S. S is 0 and
0.
R is also 0. So both are 0 means
Memory.
what is in the memory?
1.
1.
So it will be 1. Okay. Then again time to change the result. So what is the value of S? 0. What is the value of R? 1. So
0.
0.
0.
yes, reset. So 0. Now here 0 and this is 1 at that instant. So
0.
again 0. Now here again change the result. So you can see S is 1, R is 0. So now
It should be 1.
1.
will be set. Clear or not?
Yes, clear.
Q bar you can draw. It's complement. So 1 1 1 means 0. 0 0 means 1. And this is Q bar. Any doubt? Any confusion?
Fairness.
Hmm?
Clear.
These table, this equation, which I'm going to explain you now, these things we will use for solving the questions. Actually, we need to solve the questions also for SR. We need to do the designing and analysis, and then we need it. So now, here, you know the truth table. So truth table is very much clear to you. You know already. If clock is 0, whatever the value of SNR doesn't change, means as a memory. If this, then no change means as a memory. If R is 1, means reset. If S is 1, then set. If both are 1, then invalid. It is clear to everyone, huh? Hello?
Yes.
Yes,
Yeah.
miss.
Now from this
Yes.
table, I will get the characteristic table. Okay. What is the characteristic table? For the characteristic table, you need to have the value of Q0, means 3 variable. You have S, you have R, and QT plus 1. So now, if both are 0, 0, then it will work as a,
Memory.
and what is in the memory?
0.
So what is the output here?
0.
Okay. Now here check. R is 1, so 0. Now S is 1, so
1.
if both are 1, so
Invalid.
invalid. Don't care. Means it can be 0 also, it can be 1 also. So I can write here, don't care. Clear?
Yes.
Now both are 0 means memory. And what is in the memory now?
1.
So 1 here. R is 1, so 0. S is 1, so 1. And both are 1 means don't care.
Invalid.
Clear?
Yes, miss.
So we draw from this table, we draw this characteristic table. And we can find the characteristic equation. So from this characteristic table, I can find the characteristic equation. How can I find it? I need to draw the K-map. So we have the value of Q0, S, R, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So you have 0, 1 at 2, 1, 3, don't care. At 4, 1, okay. At 6, 1, 6, 1 here. And at 7, don't care. Clear? The K-map?
Yes.
So pairing. So what is Qt plus 1 is equal to, it becomes, this value is S plus this pair with this, it will be Q0, and from here it will become R bar. It's clear? Hello? It is K-map.
Yes, clear.
Yes, miss, it's clear.
This is called characteristic equation. Because this is characteristic table, this is characteristic equation. Girls, you should always remember these things for SR, for other flip-flop also, because we need to use this equation for designing and analysis. Now, the excitation table, and excitation table will be the part of this. That means it will, first you need to know the characteristic table, then you can make the excitation table. So I will explain you the excitation table. For excitation table, we have Qn. We have Qn plus 1 means present state, and this is the next state, and this is S and R. So what we will do here, two variables, so there will be 4 combinations, 0, 0, 0, 1, 1, 0, and 1, 1. And now from the characteristic table, we need to check the value of Qn and Qn plus 1, 0, 0. So we need to check what will be the value of S and R for that. Okay. So let's start. Qn and Qn plus 1 is 0, 0. Okay. So check. Qn is 0 and Qn plus 1 0. Clear? You got this condition or not?
Yes.
Then check, do we have another possible way for the same? Any other way also?
No.
Yes.
Yeah,
Look,
yeah,
check.
yes.
Q0 is 0 and Qn plus 1 is 0 or not? Check. Do we have that means for this condition we have two values, huh?
Yes.
So for if Q0 and Qn plus 1 is also 0, for that, what is the value of S for both cases?
0.
0.
So S is 0 here. But what is the value of R?
0, 1.
0 and 1. So what I will write here? Don't care. That means don't care will represent, it can be 0 also, it can be 1 also. Is it clear?
Yes.
Okay. Now Qn is 0. Okay. Qn is 0. And we want Qn plus 1 is 1. This condition. Check. Do we have any other possible way for this condition also? 0 and 1. Check. 0, don't care. 0, 1. No, we
No.
don't have. Do you have?
No, we don't have.
So what is the value of S? S is 1, R is 0. Clear or not?
It's clear.
Clear.
Okay. Now the another 1 and 0. So check 1, okay, 1 and 1. This is 1 and 0 condition. So we got another 1 and 0 condition. What is the value of S? S is 0 and R
0.
is 1. Clear or not?
It's
Clear.
clear.
Okay. Now the last condition, we need to check both are 1, 1. So let's check.
There's 2.
There is 2, yes. One here. You can check the blue one. 1 and 1 and 1 and 1. So for these blue cases, girls, can you check what is the value of S for blue circuit?
This changes.
It's changing.
It's 0
If
and
it's
1.
changing, then we
Don't
should
Don't
use
care.
don't care. And then what is the value of R?
Zero.
Same or not?
0.
Same.
So this is called excitation table. So 0 don't care, 1 0, 0 1 don't care. 0. I explain you this if you forget in the exam how what is the excitation table, but you know girls, you need to memorize it, you need to always remember, but maybe if you forget you can find in this way. Clear?
Yes. Yes. Yes.
So you can see everything we are getting from this truth table. Huh? For if we know this truth table, we can draw this. After that, we can get this, and from this we can find the equation also. Clear to everyone?
Yes, Miss, clear.
Now D type positive H triggering. What is this, girls? This is, that means for D type, this is the circuit. And here the complete circuit is in the box. So which circuit you see, that means this circuit is in the box. But you should not learn that how to make this circuit. Just you should know that this is the triggering circuit. That's it. Audio recording is on, girls?
Yes.
Yes.
Okay. So here age triggering we have done. That means this circuit is represented by this, and girls, no need to draw this circuit again and again. As I told you, we need to draw the box diagram. So we have positive edge triggering, that's why we have only triangle and the line. If we have negative edge triggering, we will use the bubble also. Clear?
Yes.
Now D flip-flop here. Okay, I will do this. Do you know here, this is the clock, this is the D, and this is the output of the flip-flop, and this is the output of the latch. So now you can understand the difference between clock and the latch, that what the result will be changed. Huh? Ready?
Yes.
Okay. So first we are going to draw the waveform for the flip-flop. So we need to draw this. Huh? We need to draw this and draw this. And for D flip-flop, if I am going to use flip-flop, I will use the positive edge triggering, because this is positive. So I'm going to use positive edge triggering. And for the flip-flop, you know that D flip-flop, if there is a clock, if there is a clock and there is a D, if no clock, so whatever the value of D, always it will work as a memory. If clock is there and D is 0, then it will become 0. If clock is there, D is 1, then it will be 1. The table is clear?
Yes.
Hello, girls. Everyone is understanding or not?
Yes, it's clear.
Yes.
So, for positive age triggering, we need to check before the clock. So clock is 0. If clock is 0, it will work as a memory. Clear?
Yes.
And girls, because in this one they didn't give us the initial value. So if they have given in the question the initial value, then it's fine, we can consider that. But if they didn't give us, then we can always consider 0. Clear? What we need to consider always?
0.
0.
That's why it is 0 here. Clear or not?
Yes, miss.
So this is 0. Now check, because at this instant the result will change at instant 1. So check what is the value of D here.
1.
1. So that's why it will be 1 till to the next. Now here the value will change. So what is the value of D here?
1.
So if it is 1, it will be 1 till to the next. Clear? Now
Yes.
what is the value of D here?
0.
So it will be 0 till here. Now check what is the value of D here.
0.
So it is 0. Now what is the value of D here?
1.
So it is 1. Now what is the value of D here?
0.
0.
So 0. Clear or not?
Yes.
Okay. Clear to everyone, girls?
Yes.
Now we want to draw the circuit for the latch, the waveform for the latch. So for the latch will work here for positive level. That means we need to check the result for the complete time period. Huh? Understand? Not for an instant, for the complete positive cycle. Okay? Hello?
Yes. Yes, okay.
Now we are going to draw the waveform for the latches. Huh? So for the latches, even the table will be the same. I will write here enable, and here will be 0. And if D don't care, then the output will be always memory. If enable is 1, D is 0, so 0. If enable is 1, D is 1, so 1. Clear the table?
Yes.
So no clock here. Clock is 0. For the clock is 0 means here we will consider the initial value 0. Now here the time where clock is here. So for this instant, for the complete period, what is the value of D from here to here? Check.
1.
1. So that's why it's 1 till to the next. Okay. Now for this instant from here to here, what is the value of D?
1.
1.
Again, it is 1 till to the next. Okay. Now for this instant from this point to this point, what is the value of D?
0.
0. So till to the next, it will be 0. Okay, girls?
Yes.
Now check for this instant for the complete level from here to here. What is the value of D?
Also 0.
0.
0. So till to the next 0. Now for this time period, the blue one, check the value of D. First D is 1. Then after sometimes it becomes 0. Can you check this? The changes?
Yes.
That means first it is 1 and then it goes to 0. So same we will draw here. First it is 1 and then go back to 0. And because it's 0, so till to the next, it will be 0. Clear or not?
Yes, miss.
Now, For this instant, the red, this one, 5, or I don't know what is this instant, 5 to 6. You can see the value first 0, then it becomes 1, and then this. That means we need to copy the same as it is here. So first it is 0, then becomes 1, then again 0. So this is the output of the latch. Clear or not? And I hope you understand the difference between latches and the flip-flop.
Miss, could you repeat the difference between the latch and when you
The
write of
what I need to explain? I didn't get it.
Yes, I didn't understand why we write the latch is different than key off. We are actually just comparing with D. Why this the
No, no,
answer?
no, not with D. Actually, it depends on the D. For the flip-flop, we are checking age triggering. You know what I draw before? I was checking the age triggering. But for the latches, what I am checking? The labels. Hmm? The before diagram, I was checking. In the before diagram, I was doing this. I was checking the value at this instant. Huh? The D is 1, so it is 1. If D is 1, so it is 1. If D is 0, so it is 0. If D is 1, it is, if 0, then 0. If here, look, D is 1. So I will not check what is in between. I will not check this. I will check only at that instant, at the age. It is called age triggering, the flip-flop. If it is 1, so 1. If it is 0, so it is 0. That is the flip-flop. But for the latches, what is the difference for the latches? You need to check the enable, and enable works for the label triggering. So for the latches, we need to check the label. That means the value, if value of D changed during this time duration, we need to mention the changes in the output. Even here, if D, I need to check from here to here. I need to check the value of D from this point to this point. I need to check the value of D from this point to this point. Now for this, I need to check the value of D from this point to this point. So first it is positive and then becomes 0. And for this instant, I can see the value of D first 0. Look, first 0. After little bit instant, it becomes 1. So I did the same.
Yes, now it's clear. Thank
Okay.
you.
So very important to understand the difference between latches and the flip-flop. So latches, these latches works with the label triggering, and the flip-flops works with the ages, the instant. At that instant, at the age, what is the value you need to check? Clear, girls?
Yes, miss.
Okay, waveform of D flip-flop. The waveform is already here, so I will not explain you this. Now you need to solve this. For the D, check it is flip-flop or not. Determine the output of the negative going. Negative going means this negative is clear.
Yes, yes.
Okay, for the given input waveform, which output Q initially 0. So initial value means it is in the memory. What is the in the memory now at the initial?
0.
0. So now who will draw the waveform on this screen? Very simple, because it is for the D. Who will draw? Who can write on
Miss, how
my?
can we draw it?
You cannot write in my screen.
No, I don't think I can.
Any other student can write on my screen? I think you can write. If you are using, I think, Android phone or Android device, then you can write it.
Miss, we join from our laptops.
Okay. No one is using the things in which way you can write on my screen. Okay, so if you are using laptops, then you can write with the cursor.
Let's say I can write. I joined
don't
from my iPad.
Okay.
So what we have to solve?
Here, check. Is there clock before the negative?
It's 0 here.
Yeah, the clock is 0. So if clock is 0, then it will work as a
Memory
memory. And what is in the memory?
0.
So it is 0. Clear?
Yes.
Okay. Now this is the time to change the result, this age. At this age, what is the value of D?
0.
0. So
So
till
it's
to the
0.
next, what will be the value output? 0. Till to the next. Any doubt? Yes, correct. Here. Now check for this instant, what is the result? Check. Who is writing on my screen?
Me. Liam.
So check, what is the value of D?
It is 1.
1.
So
So
it's-
draw.
Why it's like this? To know, miss, I draw it clearly, but go to the next.
Okay, so no problem. I am drawing now.
Yes.
So this is 1, huh? Now
It's
check,
better.
what is the value of D here?
0.
0.
Goes down. Now check, what is the value of D?
0.
As well 0.
0. Here, what is the value of D now?
1.
Clear?
Clear.
Yes.
Now girls, as we can see, for the using D flip-flop, look, the diagram I will show you. For the D flip-flop, what we have done? We use here a single input. Okay, so that's why D. But you know, I want 2 input also. So that's why there is a JK flip-flop, and it is also constructed with the SR. Okay, so the base is SR. So this is the JK flip-flop. Can you see the diagram? This diagram, this gate 1, this 2 gate, 3 gate, 4 gate. You see this diagram before or not? Check. Are you familiar with this diagram?
Yes, we took it.
Yeah, yes, you, because this is the part of SR. I was writing here S, I was writing here R. Huh? Do you remember?
Yes.
But what is the new thing we did here? Look, the output is the final output will be the part of the input. Huh? This is the new thing. Even here, the output Q bar will be the input of this, and because of this arrangement, do you know the invalid condition can be removed. Now the invalid condition will remove. Understand or not?
Yes.
So J is equal to S and K is equal to R. It will be like this. So it's called JK flip-flop or JK latch. Clear?
Yes. Yes, miss.
Miss, why here the when it is go the don't care or the invalid, sorry, in this case.
Invalid. No. I am saying because we did these 2 extra red wires. Can you see these red wires which I draw?
Yes.
Yes. Due to this red wire, do you know, it will remove the condition of invalid. Means both inputs will be 1 1. Then it will not give you 0 0 because reverse is here. Q bar is the input of this and Q is the input of this. So you will not get invalid condition. I will tell you what will you get. Huh?
Okay.
So let's start. For the JK flip-flop, if inputs are 0 0, huh? If inputs are 0 0, then it will work as a memory, no change. Clear? Same as R. This is S, this is R, like this. Clear or not?
Clear.
Yes. Yeah.
Okay. If K is 1. K means R is 1. So K is 1 means R is 1. So if R is 1 means
0.
0. Reset. If J is 1, J is 1 means S is 1. So if this is 1, then
1. 1.
set. If both are 1, so do you know what you will get? You will get the complement of previous stage. So what is the previous stage here?
1.
1.
So
So you
we're
will
going
get
to check
here,
0. Yeah.
yes, so you will get 0. So do you know, using this arrangement, what we did here, the invalid condition is removed. So you can say that this is the updated version of SR flip-flop, and we face the difficulty in SR flip-flop of the invalid condition, and we remove this condition in JK flip-flop. Clear or not?
Yes, miss.
So it is just update, not another type of a flip.
Not another, yes, just the updated version. And you can see we are always updating. You know what we did in D flip-flop? I converted into a single input and I use NOT gate, so both cannot be 1 1, huh? And even in his here in JK, what we are going to do, I'm just updating here, I'm trying this, and then I got the result and there is no invalid condition, and it has 2 inputs, so it is similar to SR completely. Can you see this?
Yes.
Yes.
So this is not a new circuit. You can say it is the updated version of SR, but we get the condition, we remove here the condition which is called invalid. So always we need to use this JK. This is a really good one because there is no invalid condition. Clear or not?
Clear.
So, Miss, in exam, you will mention that it is GK or SR to recognize the or differentiate between the truth table, or it will
Yes,
be
you
always
should know.
GK.
Yeah, you should know the truth table of each. Look, if I draw this circuit and I will ask, I didn't mention here Q, J, and K, and I ask which circuit is this? So tell me, what will you say?
No, GK.
Okay.
It is JK because we have the feedbacks here. Look, final feedbacks. Because this feedback you didn't see before. Am I right?
Yes,
Yes.
Miss.
So this is JK. And you should know the table. For the JK, it's similar to SR. Only the condition of 1 1, it will give the complement of previous. That's it. Clear?
Okay, Miss, clear.
Okay. Now JK flip-flop, draw the waveform. So I will, it's already here the output for the first one. So we will draw the second one. Let's draw. So first we need to draw the truth table. So you need to know the truth table. Clock is 0, J and K, and the Q. If J and K is don't care, means any condition, J can be 0 0, J can be 1 1, always it will work as a memory. Clear?
Yes.
And if clock you are giving both are 0 0, then it will work as a memory. If you are giving the clock and K is 1 means reset, so 0. You are giving the clock, J is 1 means set 1. If both are 1, it will give the complement of previous. So previous is 1, so it will give the 0. Clear?
Yes.
Clear.
Yes.
Okay, let's start. So determine the output of the Q for this, and initial value they have given us 0. In the memory there is 0. Okay. So before the clock, here clock is 0. What is the Q? Q should be
0.
0.
0. Now here we need to check the value of J and K at this instant. J is 0, K is 0. So if both are 0, then
Memory.
Memory.
memory is 0. So
Yes.
0. Now here J and K, check what is the value of J.
1.
So the
1.
output will be
1.
1. Now check here. What is the value of J and K?
0.
1.
Really?
Sorry, 1.
1.
One. Now check here. What is the value of J and K?
0.
J is 0, K is 1. If K is 1, then
0.
reset. Okay, good. Now here J is 1, K is 0, then No,
One.
both are one. Look,
Both
here
are one.
both. Yeah, both are one. So both are one means
The
So
complement. Zero.
no complement.
No,
So
one.
Complement. It will be
One,
one.
so it is zero complement of the previous. What is the previous? Previous is zero. So what will you get here?
one.
One.
One. Yes. Now this is one and again this is one. So if both are one, you will get the complement of previous. So what is the previous value?
Zero.
One. One.
One.
The
So what is the
previous
output
one.
now?
The output will be zero.
Yes.
Very good. Clear or not?
Clear.
Yes.
Understand, girls?
Yes.
Now, do you know, whatever the table we draw for the SR, we need to draw the same table, same equation for JK also, for D also, and one more flip-flop is also left, which is called T. So we need to draw everything for all. So let's draw the characteristic equation, characteristic table for JK. So we know that here J and K, this is Q0, this is QT plus 1. So if both are 0 0, if both are 0 0, then it will work as a
Memory.
memory. And what is in the memory? Here is 0, so this is 0. Here is 1, so this is 1. Is it clear?
Yes, clear.
Okay. Now K is 1. If K is 1, then
One.
Let's reset.
It will be zero.
K is 1.
Zero. No, one.
Why?
Zero.
J is
It
S,
Oh,
will be
sorry.
K is R.
Zero. Zero. Sorry.
Yeah, now J is 1.
One.
Now both are 1.
complement of the
The
previous.
complement.
And what is the previous in the
Zero.
memory? So it becomes
One.
1. Here, and what is in the memory? 1. So it becomes
Zero.
0. Now for the equation, you need to draw the K map, So at 1 1 4 5, at 6. So what will you get? So QT plus 1 is equal to K bar Q plus J clear or not?
Yes.
Clear.
So this is the characteristic equation for JK flip flop. Any doubt? Any confusion?
Clear, miss.
Here.
Do you want break or I can continue?
Continue, please. It's okay to continue.
Oh. Now the characteristic equation we have done already. So this part we have done. This is the characteristic equation.
Some gears want to have a break.
Okay, fine. So after 10 minutes, inshallah, we'll start. So 9:03. I will stop the recording till then. Hello, girls.
Yes,
Hello,
ma'am.
miss.
All are here?
Yes. Yes.
Yes.
Okay, so let us start. So for JK flip-flop, so we have done the characteristic equation. Now you can JK flip-flop using D flip-flop. So what will be the diagram for JK flip-flop, girls? So we have to input J and K, we have to output Q and Q bar. This is called JK flip-flop. Okay. So now, if this is the equation we have done on T flip-flop. Look, for the T flip-flop, here you can say T flip-flop comes with JK. That means what we are going to do, we have JK flip-flop and I'm going to combine both input with a single input, then it becomes the T flip-flop. So for T flip-flop, what will be the equation here? If T is 0, then it becomes the QT. The result will be as the QT. And if T is 1, it will give you the complement of the previous result. So this is called, this is the equation for the T flip-flop. So for T flip-flop, if there is no clock, T is don't care, means it can be 0 or 1. So it will work as a memory. If you are giving the clock and T is 0, then it will give you the previous result, QT. But if you are giving the clock and T is 1, it gives you the complement of previous result. Clear or not?
Yes.
Yes, clear.
Yes, Miss.
Now, the table for all. Here you can see this is the D flip-flop to table. This is for JK, this is for T and girls. So total, I explain you 4 flip-flops, SR, D, JK and T. But you know SR is the base of all. But we will not use SR anywhere because it has the invalid condition. So you need to learn the other flip-flops. So that's why I write here the truth table for D, JK and T. Clear?
Yes.
Hello.
Clear.
And girls, it is called toggle condition also, because do you know you will get, if it is 0, it is 1. Again you will get 0 1. So it is just 0 1 0 1. So that's why it's called toggle flip-flop also. And this condition is called toggle. Now here the equations, girls, you need to know these equations because we will use this one for the problems, to solve the problems. So this is the D flip-flop, QT plus 1 is D, QT plus 1 is this, and QT plus 1 is T XOR Q for the T flip-flop. For T flip-flop, I can tell you how did you get this. Wait a minute. So QT and QT plus 1 here is QT and T and QT plus 1. So 0 0 0 1 1 0 and 1 1. So if T is 0, it gives you QT. Okay. If T is 1, it gives you the complement of QT, so 1. If T is 0, it gives you the QT. And if T is 1, it gives the complement of this. So can you see the truth table? Which gate is this?
XOR. XOR gate.
Yes, that's why QT plus 1 is equal to T XOR Q. This is the characteristic equation for T flip-flop. This is for JK and this is for D. And I told you girls, T is called transparent flip-flop also, because whatever the output, it will equal to the D. Look, you can see from the table, even if D is 0, QT plus 1 is 0. If D is 1, it is 1. So both are equal to each other. Clear?
Yes, miss. Clear.
Truth table for all, you should know the truth table, the excitation table, So you should know all these things. So here you can see for QT and QT plus 1, for D flip-flop is equal to QT plus 1. So this is the equation for D. For SR, we have done 0, don't care, 1, 0, 0, 1, don't care, 0. For JK, even we can find, so then we will get this equation. For JK in the same way as we did for the R, and for T, it will be the XOR 0, 1, 1, 0. So this is called excitation table. So do you know this table you should know for all. You should always remember these things. Anyone has any question, any doubt?
No, Miss, thank you.
So if you have QT and QT plus 1, this is the equation, this is the value for SNR, this is the value for D, and this is the value of J and K, and for T, it will be the XOR, like this, okay? Now flip-flop with direct input. So there are some other inputs also for the flip-flop. So if we have flip-flop D, this is the clock. And you can see here, this is R bar. That means this one will use as a reset. Girls, do you know the flip-flop, as I already told you, the flip-flop will store 1 bit at one time. Clear? You know this? Hello? The flip-flop will
Yes,
store how
Miss.
many bits? Only 1 bit. But girls, so whenever you are saving your data, so you have only always 1 bit data. Tell me. The
So
1
did
bit,
you ask?
the one flip-flop is enough to save the data. 1 bit data is, that means you can use always the device which is working with 1 bit, huh? That is
Yes.
enough for you?
No.
No. So we need to use more flip-flops, huh? So if I am working with 8-bit data, I need 8 flip-flop. Clear?
Yes.
Yeah. So do you know why we are studying the direct input? Because if I have 4 flip-flop, and maybe 4 flip-flop has this data, okay? So I want that all should be empty, all should be reset. So what should I do? Look, I have a reset button, and I will give this value is 1. So reset means all should have 0, 0. So that's why we are using direct input. Actually, we need to give the direct command to all. So there is no need to give the individual command for each flip-flop like this. That means I'm not giving the individual command like this one is reset, this one reset, this one reset, this. No, I'm going to combine all, and then I will give the common command that make it reset. So all will be 0, 0. Clear or not? The concept of direct inputs.
Yes, it's clear.
Hmm?
Miss, can you repeat?
Yeah, look, as you are girls, you are in the class, huh? So all there are, I think, 25 students or 30 students. So do you have a separate teacher for each student, or you have a common?
Common. Common.
Common. So
Common.
is it useful to have a separate teacher? It is a wiseful decision to have a separate teacher for each
No, it's
student.
No.
Yes, it's not. So same thing is here for the, like, if I have, you know, we cannot use a single flip-flop all the time. We need to use the multiple flip-flops. Maybe we have to work with 8, we have to work with 4. So if I want to give them the individual command, so that will be easy, it will be fast. Or if I give the common command to all.
Common command.
Common. So that's why we have the direct input, so which we are going to learn flip-flops with direct input. So I will give all are connected together, and I will give the command reset. So reset means all will be 0, 0, 0. So that means if I give this command 0, 0, 0, so all will be initial at 0, 0, and all flip-flops reset at the same time. But if I have 4 flip-flop and I am going to reset everyone individually, reset, 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 reset. So it will take time, or this will take time. Which one will be good? The first circuit or the second circuit?
The second one?
The first.
The first
So
one.
which one will give you the fast result? Second circuit or the first circuit?
The first one.
First one. So these are called direct inputs. Okay. So direct you can give means we are connected all together, and you will give direct inputs and you will get the result fast. So now we are learning these direct inputs. Clear?
Yes.
Okay. Now you can see here. R bar. Here reset bar. Huh? So that means for this one, if you draw the truth table, if R is 0, look, if it is 0, I think this one will be difficult for you. Look, if I draw this, here is R, this is D, this is Q, this is Q bar. Look, so if I'm drawing this table, this is R, this is D, this is clock, and this is QT plus 1. So if R is 0, R is 0, and whatever the value of D, and you are giving clock or not. So if R is 0, could you tell me what will be the result here?
Is 0.
R is 0. R is 0 means?
Reset.
No. Whenever you give 1, then it will be reset. R is 0, that means there is no problem in this. Look, the circuit will work normally or not?
So it is the memory, from the memory.
You are not giving the clock. If you are not giving the clock and R is, okay, I will write another way. Wait a minute. Not this. Okay, R is 1, make it 1. First, if R is 1 and R is 1, and whatever the value of D and whatever the value of clock. So check, if R is 1 means reset condition is active or not?
Yes, it's active.
Is active. So if R is 1, what will be the output all the time?
0.
0, because it is reset condition is working now. But if R is 0, so that means normal. And if D is 0 and you are giving the clock, so what will be the result? Hmm? Hello, it is D flip-flop. So D flip-flop is QT plus 1 is equal to, you know that?
0. So 0.
0. If you are giving R0 and D is 1 and you are giving the clock also, so what is the output now?
1.
So that means if you want to work with this, the flip-flop normally, what should be the value of R?
0.
0. That means if R is 0 for this circuit, if R is 0, it works normally, D flip-flop. But if R is 1, then whatever the value of D, whatever the value of clock, then
0.
0.
0. Clear? But what are the changes here for this second circuit? It is with the bubble. So with the bubble means if R is 0, so 0 and with 0 means 1 here. So R is 0, then it will give you the result or not?
Yes.
Yeah, that means it will work now, reset, huh?
Yes.
But if you want to work as a normal D flip-flop, then what should be the value of this R?
1.
1. So if this is 1, because if this is 1, then this is with the bubble 0. That means there is no reset condition. So it will work as a normal D flip-flop. So if D is 0, you are giving the clock. So definitely output will be 0 as equal to D. If you are giving 1 and D is 1 and clock you are giving, so it will give you 1. So that means in this condition, it will work as a D flip-flop normal. Clear or not?
Yes, Miss, clear.
So sometimes you have a flip-flop which has the direct like this R, and sometimes you have with the bubble also. So if the bubble, so if you know this without bubble, so bubble will give you the reverse only. Clear?
Yes.
So Miss, we write the value of R before it goes to the bubble. And when it is work as a normal flip-flop. We if it is 1, and then it will go to the circuit as a 0, but we write it in the truth table as 1, and then have
Okay,
the
here is the bubble. So if 0 you are writing means you are giving 0, but look, due to this bubble it is receiving 1, means it is the condition of reset. Can you see? That means the circuit will understand that I need to be reset.
Mhm. Yes, okay.
Okay,
Yes, I understand now.
fine. Then reset condition we have done. After that, preset. Reset and clear is the same. You can say clear or the reset. And preset. Do you know preset means you need to make 1. The output should be 1. Preset. That means preset means make it set. Huh? Preset. So output will be 1 in this condition. So what should we do? So this is the homework which I am giving you for the next class, girls. You need no need to see this, you need to do yourself. Okay, from your understanding, this is the D, this is the Q, this is a Q bar, and this is the condition of reset or the clear. Okay, you can say reset or clear, and this is the condition of preset. Preset means you need to make 1. Okay, so girls, this is with bubble, but I don't want you to solve this with the bubble. You need to do without the bubble and draw this table without the bubble. Clear?
Yes.
Yes, it's clear.
Okay, so you need to solve it before the next class. So then we have done till here. In the next class, inshallah. So I will start from the analysis and designing part, analysis of clock sequential circuits in the next class, inshallah. Okay, girls?
Okay.
You have the class, huh, next week. There is no holiday or something, huh?
Yeah, we
There
have
is
a
no.
class.
Okay, that's fine. So inshallah, next week I will start this. That's it. Attendance I will take from the Zoom. Okay, girls?
Okay.
Fine.
Okay, Miss, thank you.